Hey guys, hello everyone and welcome to the channel. So welcome to the third part of Inorganic NMR Spectroscopy. In the previous two parts we have discussed about that how we find out different types of species in a molecule, number of signals, how we find out in a particular given inorganic molecule. We have also discussed about the J coupling, like how coupling takes place between the species. We have discussed about 1J coupling, 2J coupling, 3J coupling, and we have done that in the previous part. So in case if you have missed those parts, I'll give you link in the I button. You can just watch those parts as well, right? So today in this video I'm going to talk about the third part, that is going to be about intensity of the peaks. So when the peak splits out, there will be certain intensity of those peaks, and that's what we are going to talk about in this video. The idea is quite similar to what you have studied in organic spectroscopy, but yet because here we have multi-layer of splitting which is happening, there are different types of coupling which is taking place. So that's why it is important for us to understand the spin multiplicity and the intensity of the peak. I'll also take some question based upon that how the intensity of the peak adds up and how you are going to find out the overall intensity of the peak. So that is going to be the overall thing which we are going to discuss in this particular video. So stay tuned for that, watch the video carefully till the end, make your short notes, and without wasting any time, let's continue with our video. Alright, so I'll talk about the intensity of the peak. Alright, so intensity of peak is basically defined based upon the I values. Okay, so there are two types of I values which we generally study. The I value, if the I value is half, that means various different nuclei which have I value half, under which we have proton, we have 13C, we have 31 phosphorus, we have 19F, all these molecules, and we have 15N. So all these molecules have I value half. So for all these molecules there is a rule called as Pascal rule or Pascal triangle rule, or whatever you call it. So Pascal rule of splitting or Pascal rule of intensity is basically followed. Then there are molecules which have I value not equal to 1/2. For them non-Pascal rule is going to be followed. So generally the one which is most common is I value is equals to 1. For that you get you get deuterium, then you get 14N. So these are the species which have I value 1, and for these kind of species we follow non-Pascal rule. Okay, so non-Pascal rule. So let's talk about that, what this Pascal and non-Pascal rule are. So Pascal rule is pretty simple. See, if you have I value half, okay, let me use the other slide. So basically if you have I is equals to 1/2, so you know multiplicity you calculate by this formula 2ni plus 1. Now we have I value half, alright, so we can substitute I value half over here. So our reduced form for I is equals to half, the formula becomes 2n into half plus 1, and this 2 and this 2 get cancelled out and you get n plus 1, right? So this is the reduced form of it. So n depends upon that how many nuclei you have having I value half. So let's say if n is equals to 0, n is equals to 1, n is equals to 2, n is equals to 3, n is equals to 4, n is equals to 5, and so on, right? N is equals to 6, n is equals to 7. So for n is equals to 0, and the number of, okay, so here I'll write down number of peaks or splitting. Okay, so number of peaks or basically splitting. Okay, so for n is equals to 0, if you put n 0 you will get 1, for n1 you will get 2, for 2 you will get 3, for this you will get 4, for here you will get 5, for here you will get 6, here 7, and here 8. That's how you will get. Now let's talk about the intensity of these peaks. Okay, so intensity of these peaks. So it's pretty simple to do that. If it is one peak, the intensity will be 1. If there are two of them, then the intensity will be 1:1. Alright, 1:1. That's the ratio of the height of the peaks. If there are 3, it will be 1:2, 2:1. I'll explain you how you can do that. This is super simple to do. Okay, you don't have to memorize all this. This is super simple to do. So 1:2, 2:1. Then for 4 you have 1:2, 3:2, 3:1. For 5 it is 1:2, 4:2, 6:2, 4:1. all right. For 6 it is 1 is to 5 is to 10 is to 10 is to 5 is to 1. So how am I doing this? Okay, how am I writing this down? Have I memorized it? No. So let me explain you how I am doing it. For 1 it's 1, for 2 it's 1 is to 1, for 3 when you are doing, you just have to start from 1 and you have to end with 1, but here you have to just add these two and write it down. So I have added 1 plus 1, I got 2. Again for 4 I started from 1, then I added these two, I wrote 3 here, I added these two, I wrote 3 here, and I ended with 1. Similarly in the next one again you started with 1, you added these two, you wrote it 4, you added these two, you wrote 6 here, you added these two, you wrote 4, and then again same goes for all of them. Okay, so the next 7 you can predict along with me, right? So it will be 1, let's add them, so it will be 6, then let's add these two, it will be 15, let's add these two, so it will be 20, let's add these two, so 15, then again these two, so it will be 6 and 1. So that's how you can simply find out the intensity ratio. You don't have to memorize it. So this is Pascal rule, okay, or this is the Pascal triangle, Pascal rule. Okay, so pretty simple. For 8 you have to tell me in the comment section what ratio, what intensity ratio did you got for 8 peaks. Okay, so you have to tell me what ratio you have got in the comment section there. Now let me tell about the non-Pascal ones. So let's say for I is equals to 1, what am I going to get? So again I will have 2n I plus 1. Let's put I is equals to 1 here. So my reduced form will be 2n into 1 plus 1. So the reduced form will be 2n plus 1. Alright, this is what I am going to get. Now I will have for n is equals to 0, for n is equals to 1, for n is equals to 2, for n is equals to 3, and so on. For n is equals to 4 also let's do. So for n is equals to 0, if you put 0 here, you will just get, okay, so number of peaks, or basically splitting. So for n is equals to 0, it will be 1, n is equals to 1, it will be 3, for n is equals to 2, it will be 5, for n is equals to 3, it will be 7, for n is equals to 4, 2 4 times is 8 plus 1 is 9. Now let's talk about the intensity ratio. Okay, intensity ratio. Now understand that this will be only followed by those which have I value 1. So how to do that? For 1 it is pretty simple, just write down 1 as it is. For 3 it is 1 is to 1 is to 1. Alright. For 5 it is 1 is to 2 is to 3 is to 2 is to 1. For 7 it is 1 is to 3 is to 6 is to 7 is to 6 is to 3 is to 1. Now how am I doing it? Again there is a trick to do this. You don't have to memorize them. What am I doing? I have written 1, then 1 is to 1 is to 1. Then in the next one what I did, I started from 1, I added 2 of them and I wrote it 2. Then in the next step I have to add 3 of them. Okay, so I have to add 3 of them and I wrote it like that. 1 plus 1 plus 1 give me 3. Then again you have to add 2 of them and then like that. Now here let's see how I have written. I started from 1, then I added these 2, I got 3 here, 1 plus 2 is 3. Then I have added all these 3, 1, 2 and 3. So it got added, it became 6. In next step again you have to add 3. So 3 plus 2 is 5 plus 2 is 7. Then again I have added all these 3, I got 6. Then now because I don't have 3 numbers to add, so I have to only add 2 of them. I got 3 and I have ended with 1. So here what one thing extra you have to do is you have to add 2 of them and then you have to add 3 of them and make 3 3 pair. Okay, that's how you have to do. So let's see how we will do for 9. So I will start from 1, I will add these 2 and I will get 4. Then I will add all these 3 of them. So 1 plus 3 plus 6 will be 10. Then I will add these 3. Okay, these 3 and the, okay, so this I got here 10. Now if I add these 3, so that will be 16. Okay, then I have to add these 3 again, like I have added 3, 6 and 7. Now I have to add 6, 7 and 6. So 6 plus 7 is 13 plus 6 is 19. Alright, so I have added 6, 7 and 6 here for this. Okay, so I have added these 3 for to get this. In the next step again I have to add 3 of them. So those 3 will be 7, 6 and 3. So 7 and 6 is 13 and plus 6 is plus 3 is 16. In the next step, so I have added 7, 6 and 3 to get this. In the next step, I will have to add these 3. So 7, 6 and 3 is done, then 6, 3 and 1. So that will give me 10. Then I have to add 2 because now I don't have 3 numbers to add. So I will just end up adding 2 of them. So 3 plus 1 will give me 4, and at the end I will end with 1. So did I got 9 peaks? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I got that. So this is how we have to do. It's pretty simple. You can try the other one. You can try the other one, that is 11 peaks, and you can see the what is the intensity ratio you are getting over there. So it's super simple. Just you have to make sure that for I is equals to 1, you will never get even number of peaks. You will never get 2 peaks, 4 peak, 6 peak and so on, okay, because of the formula constraints. So that's how the peak intensity varies. Now what happens in the question? Okay, so it's pretty simple. Let's look upon a question and understand that what's going to happen over there. Alright, so this is an old question. I have taken this question in the previous video as well. So here we have discussed about P4S3, and we have discussed that how the splitting is going to take place. Here I told you in that video also that there are 2 types of phosphorus of type A and phosphorus of type B because of the different chemical environment. So phosphorus of type A is going to split because of phosphorus of type B. So who is splitting them? Phosphorus of type B is splitting it, and it is splitting it into a quartet. 4 peaks are going to come, and since we know that 31P, that means phosphorus, has I value of half, so it is going to follow which rule? It is going to follow Pascal rule. And since it is following Pascal rule and there are 4 splitting, so in that case the intensity ratio will be 1:3:3:1. So what does that mean? How this peak is going to look like? The NMR peak is going to look something like this. Okay, they will be quite closer. I am just showing you a little bit more resolved version of it. So the 2 peaks will be smaller, the central 2 peaks will be 3 times bigger than the side ones. So this is how it is going to look. Now in the same question I told you that PB, that means the phosphorus of type B, is going to split because of phosphorus of type A, because this is in the different chemical environment, and it is going to split it up into a doublet. And for doublet, and here again, because phosphorus is doing all these things, so I value of phosphorus will be used, and I value of phosphorus is half, so it will follow Pascal rule. And for 2 peaks we have ratio of 1:1. So how does that peak is going to look like? So this peak will look like a doublet like this, means 2 peaks of equal intensity. So this is how the spectrum is going to look like. So by far now, this is the third part of this video, and by far now you will be able to predict the structure of the spectra, like how that spectra is going to actually look like. Now these are pretty simple ones where only one atom was involved in splitting. Let's look upon the multi-layer splitting, okay, or where more than one atoms are causing splitting. Let's see what's happening in those type of molecules. Now again I am going to take an example from my previous video, the previous video where I discussed this example, where I discussed about the coupling, and I told you how 3J coupling is happening and how the splitting is taking place. There I told you that there will be 10 lines, but now let's extend that and understand what will be the ratio of these lines. First thing which you have to understand, that rhodium over here is having I value of half, so that is going to follow Pascal rule, and phosphorus also have I value of half, so that is also going to follow the Pascal rule. So let us look upon this once again. So what's happening exactly over here, that a single peak was coming from a proton from this hydrogen. Who is going to split it up? Of course rhodium, because that is directly attached to it. J value is less, it is closer to the metal, so it is closer to the NMR active nuclei, or the one for which NMR we are looking upon. So that's why it is going to cause splitting first, and it is going to cause splitting into 2 lines according to this 2Ni+1 formula. So it has caused splitting into 2 lines. Now what is going to be the spin multiplicity of these 2 lines? So of course 2, but what will be the intensity ratio of these 2? So when we get 2 lines, their ratio is 1:1. So they are in ratio 1:1. Alright. Now both these lines are going to cause further going to get split into 5 lines because of the phosphorus present over there. So 4 phosphorus are going to cause splitting into 5 lines. We have discussed the same question in the previous video, so that's why I'm not explaining it why it's happening, but I'll just talk about that what will be the intensity of that. So 5 lines will be something like this over here, 5 lines, and 5 lines over here as well. The intensity of these line will be like 1:4:6:4:1, and same goes here, 1:4:6:4:1. All right, so that's what it is going to happen. Now let's talk about that what will be the overall intensity of these peaks. Overall intensity, whenever you are calculating for the final peak, what you have to do is you have to multiply them with the subsequent peak from where it is coming out. Since these are 1, so that's why it's not going to make any difference. The overall multiplicity will be 1:4:6:4:1 for this set, and then again you will have 1:4:6:4:1 for this set. So because these peaks were 1 1, that's why it is not made any difference. But in case if it would be different, let's say 1:2:1, in that case the central peak would have been of different intensity. Okay, so that's a different thing. But yeah, so how the spectra is going to look like? So the spectra is going to look like something like this: 1:4:6:4:1, and we will get 2 set of this. All right, so we will get 2 set of this type of spectra. This is how the overall spectra for this molecule is going to look like. Let's take an example where these values are different. Actually, we have taken that same example in the previous video and we have discussed that over there as well. This was our question in the previous video, and I just explained that at the end a little bit, but let me explain you over here once again. Okay, what was happening here, that we were looking upon 31p NMR, so we were looking for phosphorus, and phosphorus is attached to hydrogen also directly, and it is attached to boron also directly. And in the question it was said that JPH is more than JPB. That means who is going to cause splitting first? Of course hydrogen, because it has more J value. So that's why hydrogen is going to cause splitting, and that's why, let me just erase this part, I'll just show you once again. So what is going to happen first, that the phosphorus peak is going to come up a single peak, and that's going to split up into 4 lines according to 2Ni+1 formula. So hydrogen is going to cause splitting into 4 lines. Let me just make these 4 lines. Now this is very important to note that these lines intensity will follow the Pascal rule, because I value for phosphorus is half, so that is going to follow Pascal rule. Okay, and since it is following Pascal rule, so that's why it will be 1:2:2:2:1. all right, so that is going to be the intensity ratio of them. All right, now the next species which is going to cause splitting is boron, and since boron is also going to cause splitting into 4 lines, so the lines are going to further split up into 4. But here these 4 lines will not follow Pascal rule. Why? Because in the question I value for boron was given 3/2, it's not 1/2, that's why it's not going to follow Pascal rule. So I value for boron is 3/2, and that's why it is not going to follow, it will not follow Pascal rule. So will it follow the non-Pascal rule? No, non-Pascal rule are followed for I value 1 over there. Whatever I told you was only for I value 1. Now here we don't have I value 1 either, so this is going to be something different which we don't know. Okay, so let's look upon the options now. So if you see the options, okay, option A and option B I have already cancelled out, because the initial peaks over here, it is like 1 peak coming up and it's getting broken into 2 peaks, and then further breaking up into some peaks. But here what's happening, initial peak coming up and breaking up into 4 peaks, so that is not happening in 1 and 2 option. That's why I cancelled out those 2. In the other 2, if you see, the 4th option over here says that this last peak is going to split up into this type of a splitting. And if you find out, if you zoom it up and see a little bit, you will find out that they have shown that the intensities are like this. That means it is following 1:2:2:1. That means Pascal rule. So whether so that means this phosphorus has initially followed Pascal rule, fine for that. But is this boron also going to follow the Pascal rule and going to give you the final peak? No, that's not going to happen. So that's why this option was incorrect, D was incorrect. So there will be something which is not getting followed by Pascal rule, so that's where your option is C is going to be correct. For I value 3/2, if you are getting 4 peaks, in that case all those 4 peaks will be of equal intensity and they will not follow the Pascal rule, they will be of 1:1:1:1:1. Same goes for this, so this will be like this, okay, 1:1:2, like all these peaks will be of equal height. All right, so yeah, so what will be my overall peak? See, 1:1:1:1:1, then 1:1:1:1:1. So let me just quickly write it down. Right, so what will be my overall intensity of the peaks? So let's start from here. What you have to do, you have to multiply with this value. So if you multiply 1:1:1:1 with 1, that will remain same. So 1:1:1:1:1, Now let's multiply these 1 1 1 1 with this 2. So that is going to become 2 is to 2 is to 2 is to 2, right? Then again, if you multiply these, okay, let me make double dot here just to show that these are two different peaks. So this is one set, this is one set coming from here. Then we will have 2 is to 2 is to 2 is to 2. That's the next set, and again at the end 1 is to 1 is to 1 is to 1, right? So if you see this option here, it is going through like that, right? These are 1 1 1 1, then these 4 peaks are twice long as these. So these are actually 2 is to 2 is to 2 is to 2, and this one is also 2 2 2 2, and this is 1 1 1 1, right? So that is following the correct trend, and that's the option number C is correct. So this is how multi-level of splitting happen, like if the molecule shows multi-level splitting. So that's how you calculate the overall intensity of them. Now let me give you a very good example where if the J values actually merge with each other, in that case how the splitting is going to take place, or basically how the overall peak intensity is going to change. Alright, let's take an example of very simple inorganic molecule, that is POF2H, okay, or whatever you call it. So basically its structure is P double bond O, and you have 2 fluorine attached to it, and you have 1 hydrogen attached to that. Okay, so it's a tetrahedral structure. This is how the molecule looks like. And let's say you are doing proton NMR of this, okay, 1H NMR. So basically it means that this is the molecule which you are looking for in the NMR. Who is going to split it up? First, phosphorus will split up because that is connected to it directly. Let's write down the I values, and let's first of all write down the NMR active nuclei which we have in this molecule. So one is proton, of course, then we have phosphorus, and then we have fluorine, right? I values if I write down, so for proton it's like for all of them it's half only, right? 1/2 is for phosphorus also, and it's for fluorine also. So who is going to split it up? The peak which is coming because of this proton. This is 1H peak which was coming straight a line. It is going to get split because of this phosphorus. In how many lines it is going to split? So that we can simply find out by this formula 2Ni plus 1. You can simply put N will be 1 and I value is half and plus 1. So if you solve this, so you will get 2 lines. So it is going to split up into 2 lines. Now the intensity of these 2 lines is very interesting to see. So that will be 1:1, right? Because it is going to follow Pascal rule. It has I value half, so it will follow Pascal rule, right? The next thing which will happen is fluorine is going to split it up first. So the next is fluorine is going to split it up in how many lines? So 2Ni plus 1. Now we are putting I values of F. There are 2 fluorides. I value is half and plus 1. If you solve it up, so you'll get 3 lines or 3 peaks in which it is going to split. So these are going to split up into 3 lines. All right. So this is how we are going to see the splitting. And now the intensity ratio will be 1:2:1, right? So 1:2:1. So overall intensity, if I write down, you just have to multiply over here. So overall intensity will be 1:2:1 1:2:1. So this is a general case where the J values are there and their splitting is taking place. But let's assume that the J value is also given to you in the question, and now let's see what is going to happen. So let's assume that the J value for pH is given to you as 20 Hertz. I'm just taking arbitrary value just to explain you, and the J value for FH is given to you as 10 Hertz. Okay, now the things are going to become little interesting over here. What does that mean? It means that a single peak coming from hydrogen is going to split up into 2 lines, and since the intensity ratio will be of course 1:1 only, but since it is 20 Hertz, so I can say that the distance between them is going to be 20 Hertz, right? The peak will be 20 Hertz apart from each other. The next thing is fluorine is going to split it up, and that has J value of 10 Hertz. So that means that this fluorine is going to split it up into 3 lines, and these 3 lines are actually 10 Hertz apart. And since I told it is 1:2:1, so the central line will have higher intensity, right? That's how I should write down. So 1:2:1, and that's the intensity. So let me just erase it. We already know about it, but what we have to understand now is that this distance is 10 Hertz now, okay, and this is also 10 Hertz. What is happening in this peak? This is also splitting up in the same way. And now if you see, so if I split it up into 3 lines, and if I make it like this, right, like this. So now what you will observe is these lines are going to overlap on each other, because this distance is also 10 hertz. The overall distance was 20 hertz, so this 10 and this 10 is going to make overall 20. So what will happen to this peak, that the intensity is coming from this side and from this side is going to merge, and this central peak is going to become little bit longer than expected. How much longer it is going to become? You basically have to add the intensity of them. So earlier the intensity was 1:2:1 and 1:2:1. So what will happen now? These two will get added up. So what will be my overall intensity of the peak? So overall intensity will be 1:2:2. You have to add these two. You will get it 2, 2 and 1. So how many total peaks you are going to see? You are only, okay, now since it is added up, so its height will be similar to these two. So now your total number of peaks will be 1, 2, 3, 4, 5. Earlier you were expecting 6 lines, but now you will only get 5 lines because there is merging of the peak is happening. Okay, 2 peaks have merged on each other, and because of that merging of the peak, your intensity has changed and the number of signals have decreased. And why it has happened? Because of the J values. Okay, so if in case the J value is given to you in the question and they ask you or they give you to split it up and find out the total number of peak, although this type of question has not been asked in CSIR net, although these type of question are asked in GATE exam. Okay, so that's what you have to consider. So if anything regarding it or anything related to it is asked, you have to be very careful about it. You have to add the peak intensity, and also you have to look upon that the number of signals are or overall number of peaks are going to get decreased. But this will only happen if the J values are going to become in such a way, the values are in such a way that on adding these two you are getting actually the distance between them, right? So this is one of the classic example where merging of two peaks happen and where the number of signal decreases and where the intensity also changes. So these were some examples and some questions related to multiplicity, related to splitting and intensity of the peak. I hope this thing is clear to you. The next part of this video, the next part of this series is going to contain satellite peaks, and that is very important topic. Okay, so make sure you watch the next topic video and stay tuned for that. I'll be uploading it very soon. So that's it from my side for this particular video. Thank you so much for watching. Please solve more questions related to inorganic NMR spectroscopy. So if you have any doubt, you can ask in the comment sections below. That's it for this video. Thank you so much for watching, and I will see you guys in the next one. Till then, have a great day. Bye bye. Take care. Hey guys, so I teach live on Unacademy Plus platform. Here I teach for the CSIR UGC NET category, and you can follow me over here for regular classes. You can access my free classes as well as my paid classes on this particular platform. The classes which are free, you can get that under the section of special classes, whereas in order to access my paid classes, paid live classes, you have to take Unacademy Plus subscription. So do make sure that you take the Unacademy Plus subscription to access all my paid classes, which are quite organized. The whole syllabus is being completed over there, and the classes are quite regular over there. So make sure that you take Unacademy Plus subscription by using my referral code, that is N_Huda. That's it for this. Thank you so much.